Hello, I'm Andry Layarda from 3AG Systems. Today I'll be talking to you about the principle of information density and how it applies to dashboard design. We'll see if we can redefine TMI from too much information into totally meaningful information. I will first start by talking about the different data visualization concepts that we have adopted here at 3AG Systems. I will then focus on the various principles of information density, and I will also step you through the process of applying these principles to a sample dashboard. Our goal is to add more data elements into the dashboard while maintaining the readability of it. Without further ado, let's begin. There are three different aspects to data visualization concepts: the methodology, the guidelines, and the science. To put it simply, these are the what, the how, and the why. The methodology talks about the guiding principles. The guidelines talk about the specific visualization to use for a given scenario. And the science covers the human perception engine. Human beings have the capacity to perceive and process a lot of information, and our goal here is to fully maximize the various mechanisms in the human perception engine to create more intuitive dashboards. Today, we will specifically focus on information density. Now, what is information density? It is defined as the number of identifiable information in a unit of space. An effective visualization contains high information density and maximizes the amount of available information. To illustrate this, I will use music as an example. When you first learn the piano, having large spaces between notes make it a bit easier to follow along and learn the music. Once you become more advanced, however, there's very little value in having the notes spaced so far apart. Now, this is the same piece of music with many more notes on the same sheet of paper. You can see here that the entire page of music on the left fits into the smaller area to the sheet music on the right. We say that the information density on the right piece of paper is higher than the left piece of paper. We are fitting a lot more information in the same amount of space. Not only does the musician save effort from flipping pages, you can also see how the music piece shapes out all in one place. Now, at this point, let's take the same high-level idea and apply it to a dashboard. I've taken the following set of dashboards from the Power BI Partner Showcase site. You could see the link below here for reference. These dashboards are for a retail company that sells clothing. You can see that they have separate divisions for boys, girls, men's, and women's, and these are set up as filters, so you can individually filter out which division that you're trying to look at. Now, there's also a drill down capability. So for example, here you can see that the women's division, they have several different categories: dresses, pants, shirts, sweaters, and so on. There are also two general sets of dashboards. One that show the revenue, and this next set here that shows units. Now, there's a lot of information that are being presented here, and things can get hairy very quickly. The first thing that you may notice is the filtering. Toggling data back and forth between the different divisions makes it harder to compare and contrast the different divisions. Now, you might say, well, there's the option to do multi-selection. However, once you do that, then the screen gets pretty cluttered, as you can see here. There's some scroll bars that you have to use. Some of the text don't show the full descriptions, and a few other challenges. Let's see if there's something we can do here to make the information more digestible. I'll step you through the following information density principles, apply them one by one, and hopefully help alleviate the challenges we identified earlier. we'll just take this one dashboard for now and see what happens. So the very first principle is maximizing space. You can see that in this dashboard, there's some space available in the corners that we can use to extend the viewing area. Now, another thing that we can do is, and this is somewhat controversial, is to reduce the amount of space that is being used to display the logo and the headers. Now, I'm not saying to take it out entirely. We just need to reduce the amount of space being used. After all, when was the last time you watched a movie and you see this banner on top and the logo to the left and things like that? You'll notice that the title of the movie and part of the credits usually appear at the very beginning of the movie, and that's it. The rest of the movie, the screen is only used to show relevant information, namely the movie itself, and that's it. The same could be done for dashboards and reports in general. Now, you see here, I've taken maximize the space on the corners and modified the headers just to have the indicator of what this dashboard is trying to communicate. The next thing we will do is modify this section of the dashboard and turn it into a slightly different visualization. What we've done here is change the visualization to a horizontal bar chart, and we color code the bars. Black represents current year's value and gray represents last year's values. We've also added the element that shows the difference between the year. Well, we didn't actually add it. We modified it so that it is also horizontal bars, and we've added color coding to it with green and red. The next thing we'll look at are the pie charts. Now, I'll make a business assumption here that I don't want to mark down too many inventories, since markdown means less revenue to the company in general. And the focus on the analysis will be on the percentage of inventory marked down between last year and this year. I will then take these pie charts and do the same thing, turn them into horizontal bar charts as well. And then for the very last element, I will simply take the same horizontal bar chart and make the formatting consistent. Now, as you can see, we have a lot more space to use now. So what do we do with them? The next thing we do is add more elements. Now, adding elements here is really about adding more relevant data, which was not necessarily in the original visuals, but it'll help us with understanding the data more. So what I'm going to do is borrow the same technique that I used to show the deltas between previous and current years, and then apply it to the two charts that we've just added. Now, here you can quickly and immediately see that this year we have 7% more marked down sales compared to last year. So now you could say here there's now a lot more space that we can use. What do? We can add more data. So what more data can we add? Well, let's see if we could bring the same granularity level to all the three charts. And this is what we get when we do that. Now, one thing that you might notice here is we have eliminated the need to use filters to compare the different divisions on all the visual elements on the dashboard. In the original dashboard, you're not able to quickly see the markdown percentage by division and the average retail price by division and do comparisons across divisions and also across years. Now, we're not done yet though, so there's still a lot more that we can do. The next principle that we're using here is using small components. Now, what that means is really just how far we can reduce an element before it becomes unreadable. So we'll take this and then apply the small components, and you'll see that we have effectively reduced the original dashboard from one dashboard to half a dashboard. Lots of space to work with at this point. So what else can we do? Now, how about adding more objects? Now, because we ran out of things to add from the original dashboard, let's take a quick look at the second dashboard, which is the dashboard related to availability of inventory. Now we'll take this data. So there are a few elements here. There's available units between this year versus last year, by department, regular and marked down by department. Well, we'll take all these data elements here and apply the same principles, and we'll populate the second half of the chart. So I'm not going to go through all the steps at this time, but it could be a great homework exercise if you're looking for things to do in the evenings or weekends. Applying all these principles, we end up with the following dashboard. Let's do a quick recap. So at this point, we've applied the 5 information density principles, reduced 2 dashboards into one consolidated dashboard, eliminated the need for filtering, and even have added a few more elements that were not in the original visualization. This is actually not quite true, because if you look at the original visualization, there's one thing that we haven't addressed yet, and that is the drill down capability. In our final result here, you'll see it just covers divisions. Now, I've taken, the liberty to do some homework on my own and try to come up with a visualization that could address all the different filtering and drill down capabilities. And this is one thing that I came up with. Now, one thing to note then, this is not the only way to visualize this data. This is just one possibility. Now, at first glance, this might look extremely overwhelming because you have all these data points. But I'm going to ask you a question, and that is, if I were to give you 3 seconds to look at this dashboard, I'll give you the same amount of time to look at this dashboard, which is 3 seconds, and then also 3 seconds to look at the original set of dashboards and come up with the top 3 actions that you will take based on the information that you have. You'll notice that it will most likely be a lot more obvious to figure out what's going on here. Immediately your eyes get drawn to men's tops because it's down 740,000 K this year versus last year, and women's tops is also down by quite a bit. Whereas in the original dashboard, you're going to have to do a lot of drill downs and filtering to be able to see this insight. And this is what is behind the site. This is what's behind what we call parallel processing. The human perception engine is very good at distinguishing colors, shapes, sizes, and tilts, but not all at the same time. So if you look at this example, it is easy enough for you to be able to find the one that sticks out within each area. In the color example, you can quickly find the one red circle, in the shape, the one square, in the size, the one large circle, and so on. However, once you mix all of them together, you have to process each of them in sequence. Now, in this last box, if I ask you to count how many black squares are there, you will have to scan through all the other shapes before you can say for sure how many black squares there are. Now, let's look at a more concrete example, and that is, where's Waldo or where's Wally, depending on which country you grew up in. It is designed to overwhelm your visual senses by mixing colors, shapes, sizes, and tilts in all sorts of manner that you pretty much have to scan to be able to identify where Waldo or Wally is. If we were to apply the same pop-up principle, you'll notice that it is a lot quicker to find Waldo or Wally. If you're still here with me, congratulations on making it to the end. Stay tuned for more additional content in the future where we explore other data visualization concepts and principles.